right, this reaction, or this question talks about dissolving, talks about solubility, so it's probably a KSP problem. Without really reading the question even, as soon as I know that and it's barium fluoride, I can write my dissociation. It's always of a solid thing, or we wouldn't be talking about solubility at equilibrium. It breaks up into its ions, and then we balance. I don't need to fill out my solid because it's not going to be plugged in anywhere, because KC's, KSP's, any equilibrium constant excludes solids and liquids. 0 plus S, 0 plus 2S. There's my ice chart. I could assume zeros because no initial values were given. KSP, same rules as KC, products over reactants. Coefficients become exponents, so it's squared. It's technically over 1 because the solid doesn't have a value plugged in there. You don't have to write the over 1. KSP then is S, plugging this in here. Plugging this in here, the 2 is repeated. That's normal, that's not new. That's just like KC, because we had 2S from the coefficient, and the coefficient also became the square. Now, it's barium fluoride, so I might think to go look on the chart of values, but it says we're not at 25 degrees. That means I can't use the chart. Additionally, it's asking me to find solubility product. That's KSP. I wouldn't use a KSP chart to find KSP. So I'm looking for KSP. I can simplify this, the 2 distributes. If I want to find KSP, I need to find an S value so that I can plug it in here to then get my solubility product, my KSP. Knowing the S's in molarity should help guide you. It means if from the given information I can find molarity, that's my S value. You can go from grams to moles and then moles to molarity to plug in. That's what I'm going to do. Or if you wanted, you could go from grams to grams per liter and from grams per liter to moles per liter. Mathematically, it's the same steps, just in a different order. So 5.2 grams equals moles times the molecular weight of barium fluoride. So fluorine is 19 times 2, plus barium is 137, so 175. 5.2 divided by 175 gets me moles to be 0.0297, or 0.03. Molarity, which is going to be my S value, is moles divided by liters. So my molarity value is 0.01, therefore my S value is 0.01, and I can plug it in as S. It is not my KSP value. That wouldn't have units, so not even units of molarity. 0.01 cubed times 4, I get 3.89 times 10 to the negative 6th.